Today we're both going to be reviewing what is a function, and then we're going to spend the rest of today learning about domain and range using discrete data. So first let's go back to our 8th grade review and talk about what is a function. Some of your teachers probably taught it to you as a machine where you input something, it gets processed, and you have an output. You could also think of it like a vending machine. On a vending machine, if you press the input of A1, you would expect your output to be Dr. Pepper. If you pressed your input of A7, you would expect your output to be Coca-Cola, or whatever it is. It's whatever you put in, it goes through the process, and you get an object out. If we start looking at it in people terms, as a person, I can only have one birthday. So my input can only have one output for this to be a function. So as a person, I can have one birthday and only one birthday, so that's a function. Now think of me as a person. I could have more than one phone number. I could have my cell phone number. I could have my work phone number. I could have my home phone number. So that would not be a function. That would not be a one-to-one relationship. So when we look at this, what we can't have repeating is the input value. So look at number 1. On number 1, if we look at those input values, we have a 0 with an output of 5, and then we have 0 again with an output of 6. That would be not a function because our zeros repeat with different outputs. So we can go ahead and say, nope, not a function. Okay, on number 2, we're going to do the same thing. We're going to look at our inputs because that's what we can't have repeating with a different output. So if I look, I've got an input of 4, 0, and then over here I also have another input of 4, but it gives me a 3. That's not a function. Every input can only have one output. Okay, so let's look at number 3. Number 3, each one of my inputs only has one output. 3 only has one output of 15. 11 only has one output of 15. So it is a function. Even though both of them go to 15, we're not worried about the output. It's the input that we're worried about. So yes, it is a function. Okay, so let's look at number 5. And a lot of times, what I recommend you do is go ahead and map it. Make a table. So this tells us, or it's asking us, is x equals y squared? Is that a function? And then it gives us some inputs to use. It gives us inputs of x equals 0 and x equals 1. So over here, I'm going to draw my little function table, and I'm going to put my x and my y. And I've been told that x equals 0 and x equals 1. My function is x equals y squared. Okay, so now we're just going to put it in and see. X equals y squared. So we've got 0 in for x. 0 equals y squared. So to find out what our y is, since we've got y squared, we're going to have to take the square root of each one of our x's. So if I take the square root of 0, my answer is 0. But if I take the square root of 1, the answer to that is either 1 times 1 or negative 1 times negative 1. Either one of those will give me the answer of 1. So I've got 1, and also with 1, I've got negative 1. So my x input of 1 can give me 2 different outputs. So no, this guy is not a function. Okay, what about every student in the school and their homeroom teacher? As a student, you only have one homeroom teacher. So yes, that is a function. In addition to just saying your X input can only have one output, so one-to-one relationship, if you've got a graph, the easiest way to see it is to use what we call the vertical line test. And vertical line going straight up and down, if you put your pencil to the very far side of the graph and just hold it straight up and down and start going straight across it. If you only run into one point at a time straight up and down, then it's a function. So number 7 is a function. Then let's try our vertical line test again for number 8. If we're going straight up and down on number 8, if we go straight up and down, our little red dot only hits the graph one place at a time, so it is a function. Now let's look at number 9. If I draw my little dot straight up and down, looks like I'm going through the graph at least 1, 2, 3, 4, 5 different times. So it's not a function. Look at this making connections question. It's talking about the difference in a function and a relation. A relation is just a pair of data, an X and a Y, an input and an output. So that's the more broad term as a relation. A function, not only is it an X and a Y, but you can only have one output, one Y, for every X input. So a function is always a relation, but a relation is not always a function. So this is a true answer based on all of that. Okay, so now let's move into our domain and range topic. This is the main topic of the day. It's no longer review. First thing you need to see is we have a definition. And our definition is talking about discrete data. So that's our big definition for today, is discrete data. And what that is it's items that you can count, like number of people, or number of cars you wash, or number of hamburgers sold in a restaurant. And when we look at discrete data on a graph, it's individual points or separate points on the graph. So let's just look at this. Number of children in a household. Those are individual items that you count. So yes, that would be discrete data. Height of children. This is talking about, I'm going to change it to height of a child. Make this a little more clear. Height of a child. Height of a child. So talking about the height of a child, when a baby is born, they're maybe 19 inches tall. As they grow throughout their lifetime, they're going to pass through every millimeter between 19 inches tall and however tall they end up at full height. 5.5, 6.5 feet, something in there. So that is not discrete data, because it would be a line that includes every single height between what they're born in and what they eventually die in. So no, that is not discrete data. Okay, when we look at this table, well, this table is 4 separate points, just like counting something. So no, yes, that is discrete data because they're 4 separate points. But we look at number 14, and that includes all the points on that line. So that's not discrete data. 15 is discrete data because they are separate points. 16, the mapping is very much like the table. Those are all separate points. So it's considered discrete data. Okay, so number 12 and number 14 are not examples of discrete data because they include all the points in between. They're a connected line, a continuum, as opposed to separate points. So the way we write domain and range for discrete data is we just list it out. Since discrete data is separate points, our domain and our range will be listed out as separate points. So let's just start with the words domain and range. Domain is going to represent our input. Range is our output. Or you might know it as domain is your X value, and range is your Y value. Sometimes, to help people remember it, I just say, look, it's in alphabetical order. D comes before R, X comes before Y. If you put them in alphabetical order, they'll always be in the right place. Okay, so determining our domain on this first one, I'm going to make it a little bigger. Determining our domain on this very first one, we're going to start first. Domain is our X values. So I'm going to underline each one of my X values. And then I'm going to list them out. So I've got -1, I've got 5, I've got 2.3, and I've got 4. Now, mathematically, we should put these in numerical order. So even though those are the numbers that I've got, I'm going to go back and I'm going to rewrite them in numeric order. Okay, and now we're going to do the range. So I'm going to underline the range, or I'm going to circle the range in a different color. We've got 9, 7, and -2. So we're going to go ahead and put those in numerical order from the beginning. So we have -2, 7, and 9. Now, since I'm just listing what they are, I don't need to repeat the 9. That's all we need to do. Okay, so now let's do number 18. And in a table, it's even easier. We're just going to put all of our X values, that's our range. So in numerical order, we've got a -6, a -1, a 1, and a 3. That's our 4 domain values listed numerically. Now let's do our range. We've got a -8, -4, 7, and 11. That gives us our domain and our range. Notice that in discrete data, they're listed out separately. Okay, so now let's see how to do it when we have a mapping diagram. It's going to be very much the same process. Let's bring this in just a little. So for our domain, again, domain is our X values. So I'm going to list all of my X values in numerical order. So -1, 2, 4, and 5. And my X values, you'll notice the arrows point to the Y values. That's my range. So my range is going to be -5, 3, and 10. All right, and the last way to look at it is how do you list your domain and range when using a graph? Now, the graph, the easiest way to do this, you actually have to know your coordinate points, but I want everyone to write the coordinate points for each one of these points on the graph. So we're going to start with the very first one down here in the bottom. And we're going to say, okay, I'll go -2 over, so here we are, -2 over, and 1, 2, 3, -3 down. So that's -2, comma, -3. So up here, I'm going to write the first one, -2, -3. Okay, now let's write our second point. Our second point, I'm going -1 over, and then 1, 2, 3, 4, 5 up. So -1, 5, let's put it here, -1, 5. And then my third point, I'm going to go over 1, 2, 3, 4, 5, 6, and up 1. So positive 6, positive 1. And notice how I've rewritten them on top of each other. They almost look like a table. And the reason I've done this, and the reason I want you to do it, is it makes it very simple then to write out our domain and range. So if we say, okay, all of my domain is all of my x values, that's these guys here. It's the first one in the ordered pairs. So writing them in numerical order, I've got -2, -1, and 6. And then it's very simple to circle my range values. And I've got -3, 1, and 5. So listing domain and range for discrete data on a graph. The habit I want you to form immediately is to write your 3 or 4 or 5, however many they give you, ordered pairs that go with the coordinate points. The last thing that we're going to go over is a little bit more terminology that you're going to hear and see all the time in Algebra 1, and that's independent and dependent. So if we just go over the basics on independent and dependent, independent represents our input values or our x values. So input or our x values. And the dependent variable represents the output or the y values. And in class you'll hear me refer to the poster III CDX. And when you get back to class, if you weren't here for the III CDX discussion, ask me about it and I'll show you the independent dependent poster that helps you remember all of this. So a lot of times we will use things like y is a function of x, or y is dependent on x, because y is our dependent variable. And so y depends on x, like a baby depends on its mother, or the getting a Dr. Pepper out of the machine depends on you pushing the button for Dr. Pepper. So that's what a dependent relationship is. So knowing that y is dependent and x is independent, if we look at number 21, and it says identify the independent and dependent variables. Well, we already know that y is dependent. So that's our dependent, and our x is going to be our independent. So then we have to figure out what it represents. So y represents the amount of fluid in ounces. So our dependent is the fluid in ounces remaining in the bottle. And what that depends on, how much fluid is left in this bottle, depends on our x. And our x is the number of gulps you take. So our independent is gulps. So how much fluid remains in your bottle depends on how many gulps you took. That's our independent and dependent relationship. Okay, so it's given us our domain, our input values, and it's asking what the range is. So it's asking us to take a table with our input and our output and going 0, 1, 2, 3, 4. That's the number of gulps, and we're going to put it into that equation, -3x plus 12. That's what we figured out as the formula to figure out what our dependent is. So go ahead and pause the video and plug in each of those inputs into the equation and come back and check your answers. Okay, so as I input in each one of the x values into my formula, it tells me how many ounces of orange juice are left in my bottle. And if I can look at this, how much orange juice did I start with in the bottle? Well, when I took 0 gulps, I had 12 ounces. And how many gulps did it take to empty that bottle? Well, at 4 gulps, I had nothing left in the bottle. So just starting to equate these formulas with actual real-life situations, all of our tables mean something and represent some kind of data.